starting the unit on triangles, and I love this unit. We will be doing proofs in this unit again, but the proofs are quite nice in that they're pretty formulaic. Do the given, you prove a couple of things that are like you need to prove specific things, and then your proof is done. So they're quite formulaic and they're very good, but what's more important is that triangles are the basis of like everything in construction, everything in architecture, and we can use triangles to prove so many different relationships. And so it really is quite neat when you have this background on being able to prove triangles congruent. We can prove all kinds of things are congruent once we know the triangles are. So it's really quite interesting. So we're starting by classifying triangles by the sides and the angles. So this is an example of a triangle. Oh. Hello? Yeah. Mm-hmm. Okay. Yep, bye. All right, so here's an example of an acute triangle. It has 3 acute angles, and what makes ACUTE, acute triangle? This is an acute triangle. It has 3 acute angles. What are acute angles? Less than 90 degrees. Yeah. You know what I'm going to do? I'm going to say the angle x degrees here. Each of them, x is less than 90 degrees or greater than 0 degrees. So it's between 0 and 90 degrees. All right. Here's an example of an obtuse triangle. And what's an obtuse angle? So yes, this is our larger than 90 degrees. Like that clearly is larger than 90 degrees, right? Okay. So we're going to say x, our angle here, our degrees, is greater than 90 degrees and less than 180 degrees. So an obtuse angle is between 90 and 180 degrees. And a triangle can only have one obtuse angle. And that's what makes it an obtuse triangle. All right, it can't have more than one obtuse angle. Have you ever thought about that? Good morning. Have you ever thought about that? Like, so if I have a triangle, here's one side, here's an angle that is larger than 90 degrees, and then if I draw another side to this triangle that's larger than 90 degrees, is it a triangle? This is a triangle? Oh, no, ma'am. No, that ain't a triangle, right? Okay, so it can only have one obtuse angle, and that makes it an obtuse triangle. Of course, if we have a right angle, we have a right triangle. And if we have 3 congruent angles, so we have our congruent angle markings here, very important, then we have what is called an equiangular, equiangular, equiangular triangle. Equiangular, equal angles. See how that works there? Equal angles, equiangular. Okay. So classify each triangle in the diagram below by its angles. So how do we know we're looking for a triangle? Here's the symbols. Look, it's a triangle. I love that. So we see that symbol right there. It means triangle, CDE. A triangle has 3 vertices. 3 vertices, so we will always use 3 letters to identify a triangle. And so triangle CDE, CDE is this triangle here. Tell me about the angles in this triangle. Yeah, it has a right angle, and if it has one right angle, it is a right triangle. And you're welcome to use the triangle symbol instead of writing the word triangle. Okay? All right. Triangle BCE. Turn down your volume. Turn down your volume.
I'm trying to. Doesn't like me.
All right, we're back. Triangle BCE. BCE is this triangle right here. Triangle BCE. How would you classify that triangle? Obtuse, yeah. This angle C right here looks like a very large angle. We would call that obtuse. An obtuse triangle. All right, triangle ABE. ABE right here. Equiangular. Very good. We have 3 congruent angles, so equiangular. Equiangular triangle. All right. Triangle BDE, BDE, obtuse, very good. That one's kind of nice. You can tell it's definitely larger than 90 degrees because we have our 90-degree angle on one side and our triangle goes further than that. So definitely obtuse, obtuse triangle. And then CFE, CFE, acute, yep, acute triangle. Acute triangle, we can clearly see that the angle CEF is less than 90 degrees. So that's really good, just thinking. Okay, so not only can we classify triangles by the angles, we can also classify triangles by their sides. And so here we have a triangle marked with 3 congruent sides. What do you call that? So equilateral. Equilateral. Equilateral triangle. So this would be called the equilateral. Lateral, like you hear that in medical terms all the time, like a lateral incision. That's a lateral, like an incision on the side. Okay. Yeah. Lateral fins, dorsal fins. These are all Latin words for side or top. All right. So this is equilateral, so equa and lateral means side, so equal sides. And then here, 2 congruent sides? Do we know what that is?
Double lateral.
Double lateral. It's called isosceles. Oh, ISOSCELES, isosceles. Isosceles triangle, so isosceles is 2 congruent sides, equilateral is 3 congruent sides, and then no congruent sides. Do we know what that's called? Scalene. Scalene triangle. Yeah, so hopefully you've heard those words before, but maybe not. I don't know. Have you heard? No? No? Okay. So scalene, isosceles, equilateral, 3 words that describe the sides of a triangle. So really good. Hey, sometimes I learn new things. All right, here we go. JKM. JKM is this large triangle. So what do you think? Is it equilateral, isosceles, or scalene? Scalene. So these 2 markings, which I think is why you saw isosceles, right? So JK and JN, when you mark a congruent mark, it is simply between points. So this congruent mark is only saying that JN is congruent to JK, but it says nothing about the whole side of the triangle, JM. So these are 3 different side lengths, so it would be scalene. KLN. KLN is this little guy in the middle here. Isosceles, 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 it has 2 congruent sides, so those double tick marks there mean those 2 sides are congruent, so this is isos. Isosceles. It sounds like a Greek god. I think I could become like Isosceles, right? But Hercules, Isosceles, right? Okay. Sorry. All right, then we have triangle JKN, and JKN is this beautiful equilateral triangle. We see 1, 2, 3 congruent marks there, so that is equilateral. All right, so there's our equilateral triangle. Super. So now the combo here, we are going to classify each triangle by its angles and its sides. So tell me about number 9. What's its angle? A right. Okay, so we have a right. And then what about the sides? So we would call this isosceles. ISOSCEL. Isosceles right triangle. God bless you. All right, tell me about this angle on number 10. Obtuse. Obtuse scalene is very good. Obtuse scalene. And the reason we're going to say scalene is because there are no markings on here. Because there are no markings about the sides, I can assume nothing about the sides. These might look the same, but unless they're marked or unless they've told me information, I cannot assume they're congruent. Even though they look congruent, we never assume anything in math. So we're going to keep that as scalene since there are no markings on this. Number 11, tell me about the angles. Yeah. So when the angles are congruent, equiangular. And then we also have equiangular, equilateral. Correct. So they put in some markings for me, so I'm going to go ahead and mark my angles congruent. They put some measurements for the sides, so I'm going to mark my sides congruent. So this is equiangular, equilateral. Equiangular, equilateral triangle. Okie dokie, questions so far? Good. Equiangular and equilateral. Tell me about number 12. Tell me about the angles. They're all different, it's true. Do we have any? Acute scalene is very good. Acute, all the angles are little angles. They're cute little angles, so it's acute. And since all the sides are different side lengths, that'd be scalene. I think we're good with that. You good with that? Okay. So here, I really liked this question, 15 through 19. So we have to read information. And this is the part of math that's hard, right? The reading. So let's read it carefully. It says, segment PR. So PR is this long cross piece here. So PR bisects angle SRT. What does that mean? PR bisects angle SRT. Cuts it right in the middle, so we get two congruent halves. So this angle is congruent to this little angle here. So SRP is congruent to PRT. So two congruent angles, and that comes because of bisecting. Read it and mark it on your picture. Really important. It says U is the midpoint of segment RT. U is the midpoint of segment RT. All right, if U is the midpoint, what does that create for us? Midpoint means middle. It's the halfway point. So it's halfway or right in the middle of segment RT. All right, look at here. They have this segment UR marked as 8 meters. So what's the other side?
8 meters.
Also got to be 8 meters. So they are congruent, and I'm going to mark that because that is a perfectly logical conclusion. It must be the midpoint, so that right side must be the same as the left side. All right, so now that we have the extra information there, we're going to classify each triangle by its angles and sides. So triangle UQR is this triangle right here. Tell me about that pink triangle. Isosceles, very good. Obtuse, isosceles. We have an obtuse angle here bigger than 90 degrees, 2 congruent sides. Beautiful. All right, triangle RST. Oh, RST. Oh, I'm going to highlight that triangle. Again, sometimes it's really helpful to use colors, especially on complicated pictures like this. So triangle RST is my highlighted triangle. Tell me about that triangle. Equilateral. How do you get equilateral? Yeah, so if you look at the side lengths, I've got 16 meters. What's side TR?
16.
Also 16 meters. 8 plus 8 is 16. And side TS? Also 16. So it is equilateral because all 3 sides are the same. And, we've got some more information. It is equiangular as well. This little angle is 30 degrees, which means the other one I didn't label is also 30 degrees. And all 3 angles then, 60, 60, and 60. So it is equiangular. Equilateral and equiangular. All right, triangle SRQ. SRQ is right here in blue. So there's a blue triangle. Right? Right scalene, yes. Right scalene triangle, awesome. All right, PRT. PRT is this sort of triangle on the left. These are what we call overlapping triangles. All right, so this is this sort of left side overlapping triangle over here. So we have, what did you say, Cash?
I said obtuse,
Isosceles. All right, obtuse. Absolutely, we have this nice large angle here, obtuse. And then isosceles, we have 2 sides that are 16 meters each. So obtuse, isosceles. All right. How do you feel about that? Pretty okay? All right, we're going to stop there. Super. And then not only can we classify our triangles by analyzing pictures, looking closely at pictures. We also can find the measures of the sides of triangle JKL in a coordinate plane. And then we can use the distance formula to classify it by the lengths of all the sides. So this goes right back. So here we go. The distance formula. We have ordered pairs. We did the distance formula way back. The beginning of the year. So the distance formula, big giant square root. We got to subtract our x's. x2 minus x1 quantity squared plus the quantity y2 minus y1 quantity squared. And that's all under the giant square root. So we're using the distance formula to find the lengths of the sides. All right, in a coordinate plane. And so what I need to do is I need to find, if I have this triangle, let's say JKL, somewhere floating in space. There it is, floating in space. I want to find each side. So first, I'm going to find the side JK. So I'm going to use points J and K to find the distance between the points. So big square root, and go ahead and set up your parentheses squared. So set up your little structure, and then we're going to take our x's and subtract them. So that's going to be -9 minus a -7. And I want to take my y values. So my y coordinates, 1 minus the -7. All right, x2 minus x1 quantity squared plus y2 minus y1 quantity squared. All right, let's see what we got here. Minus a negative is really a giant positive, so I'm just going to change those double negatives to pluses. All right, what is -9 plus 7? Yeah, -2. And then I'm just going to write the -2 right underneath there. What is -2 quantity squared? 4. Yeah, so that becomes 4. Here I have 1 plus 7, which is 8. And what is 8 squared? 64. 8 times 8 is 64. And so we get the square root of 68. And we can leave it just like that. That's a great, perfect, exact answer. It's really nice. All right, so we looked at one side. We also need to look at side KL. So now I'm using which points? K and L, yep, we're using points K and L. So again, I'm just going to set up my little structure here. Big square root of stuff squared plus stuff squared. And I'm using points K and L, so make sure you're keeping things straight here. So using points K and L, I'm going to take my x's and subtract them. So I have -1 minus a -9. And then I got to take my y's and subtract them. So -1 minus 1. All right, so then minus a negative is really plus. So -1 and a 9 make 8. And 8 squared becomes 64. And here I have -1 minus 1. That's -2. And -2 times -2 is +4. So once again, I get a 68. So this triangle is already isosceles. But we got a third side to check. So we're going to check JL. That's my last side of my triangle, JL. So now I'm using point J and L, so you got to be real careful. We're going to do a square root here. Set up my squares. And now x2 minus x1 using my points J and L. So -1 minus a -7. And now subtracting the y's, -1 minus a -7. All right, minus a negative becomes a plus. All right, -1 plus 7 is? 6. All right, and then 6 squared is? 36. 6 times 6 is 36. Plus, -1 plus 7 again is a 6. And 6 squared, 6 times 6 is 36. So we get the square root of 72. Now, these two side lengths are both radical 68. So we have two congruent sides. That makes it isosceles. Two congruent sides. So we have isosceles. Does that make sense to you?
Yeah.
Do you need another one of those? Or are you good with that?
I'm good with that.
Yeah. Yeah. All right. And if they were all three different numbers, it would be scalene. And if there were three of the same, it would be equilateral. Okay, perfect. Let's do one. Okay, so we can also use algebra to figure things out as well. So triangle ABC is, vocabulary, ladies and gentlemen, the reading. Equilateral. What does equilateral mean? All three sides are the same. So we're going to mark our picture. They told us information. All three sides are the same. So I'm going to give all three sides congruence markings because they're all the same. We want to solve for both x and y. All right. All three things are the same. What equation can I write, ladies and gents?
3x plus 1 equals 49.
Good. 3x plus 1 equals 49. Could I say 3x plus 1 equals 18y minus 41?
Yes.
I could, but would it help me?
No.
No. I can't have an equation with x's and y's in it. It's just not helpful at all. So we can go ahead and solve. What should I do to solve for x? Minus 1 from both sides. So I get 3x equals 48, and then divide by 3. X equals 16. All right, if x equals 16, that's great. Can I write another equation?
Yes.
What's my other equation? 18y minus 41 equals 49. Sure, that's another thing I can equate. Those two are also congruent. So 18y minus 41 equals 49. I'm going to go ahead and add 41. Add 41. So I get 18y equals 80, 90. And then divide by 18. Y equals 5. 5, yeah. All right, so we solved for x and y. So again, this is really about using vocabulary, marking your pictures. All right, questions on the first one there? All right, let's skip down to number 3. Triangle MNP. MNP is equilateral. What does equilateral mean? All three sides are congruent. Mark your picture. Find x and the measure of each side. So I need to find the measure of MN, I need to find the measure of NP, and I need to find the measure of MP. I need to find the length of each side. What you got, Kish?
If we found, like, if we did, like, the 4x and the 6x, we just plug the x value of that into the x plus 14 and then just, like, add it?
Right. Okay. Plug it back in. So that's what we have to do. So we solve for x, and then we're going to have to plug things back in to actually find the length. Yep. Okay. So what equation do you guys want to set up? X plus 14 equals 4x minus 25. Beautiful. Absolutely. That's a great thing. We could write a bunch of different equations here. There's actually 6 equations we could write, and they would all be accurate. Okay. So what are we going to do first to solve? All right, minus x, so we get 14 equals 4x's minus 1x is 3x's, and you said add 25, so we're going to add 25. So I get 3x equals 39, which means x equals 13. Good. All right, and just like before, if we want to figure out the length of the side, then I need to plug it in. So go back to our side and plug in 13. And 13 plus 14 is 27. And do I need to plug it in all the other places?
Yes.
I could, but if this side is 27, what's this side? 27, and that side is 27, because it is equilateral, right? So they should all work. It's a good thing to do. You could plug it back in and make sure. That would be good. All right, questions on that one? All right, let's look at number 5. And then we're done. All right, triangle WXY is isosceles. Isosceles means 2 sides are congruent. Isosceles triangle with segment WX and XY congruent. So we do have to be a little bit careful, making sure we mark the right sides congruent. All right, find X and the measure of each side. So I need to figure out WX, XY, and WY. all three sides when we're done. All right, how do we find x?
I would solve for the 5x minus 31, since we know that one's gonna be like a different number.
We will need to do that. How do we find x? Yes. 6x minus 77 has to be equal to 3x plus 4 because those are our congruent sides. Those are the things marked congruent, so those are the things we can set equal. All right, I'm going to go ahead and subtract 3x. I'm going to add 77 to both sides. So, what is that, 81?
81.
All right, and then divide by 3. That's a 27. That was all mental math, ladies and gentlemen.
Yeah, 27.
All right. You know how I did that? 3 goes into 8 how many times? 2 times. With how many left over?
3.
So 3 goes into 8 how many times? 2 times. That makes a 6. With how many left over? 2. So then 3 goes into 21 how many times? 7. Wow. Okay. All right. So I know that x is 27, so I'm going to go back in and plug in a 27, and I do have to plug it in a couple of places here. These two should be the same. Let's see here. 3 times 27 plus 4, 85. So xy is 85. And what's wx?
85.
Also going to be 85 because they're isosceles. And then I do need to plug in the 27 to our long side here. So 5 times 27 minus the 31, 104. There's no units on here, but we're going to pretend it's like millimeters or something like that just so we can get a sense, you know. This is a big triangle. It's not this small. It's bigger than that, yeah? All right. Do you have questions for me? All right, cool. Well, that is not too bad.